Welcome back to MOVITRAC LTE-B Plus Basic and Intermediate Training. This is Session 1. In our last session, I introduced you to the MOVITRAC LTE-B Plus family. I also talked about what you're going to learn in this class. We're now going to transition to some details about the MOVITRAC LTE-B Plus itself. I'll introduce you to its models and styles. We'll talk about its features. We'll talk about the accessories that you can get for it. But before we do that, I want to do something that might be necessary if you haven't worked with variable frequency drives much. I want to introduce you to VFDs and how they work. Now, if you know all about this, of course, you're welcome to skip ahead. In fact, all the videos are chapterized to make skipping around easy. But if VFDs are something you're a little fuzzy about, hang around for just a few minutes and I'll get you up to speed. VFDs are actually relatively simple as far as what they do, although internally they're pretty sophisticated. Let me just give you a kind of a block diagram overview of what a VFD does. All VFDs take in power. We often call this the line in. Many VFDs in industrial settings use three-phase alternating current power. That is the most common because it's the most efficient way to deliver power. But some VFDs, and this includes the MOVITRAC LTE-B Plus, can also take in single-phase alternating current. Some VFDs as well can take in direct current, but we won't be talking about that here. We'll assume you've got an alternating current-powered VFD. Now, the first thing that happens after power comes in is we convert it to direct current by passing it through a device called a rectifier. The rectifier turns it into a kind of choppy DC. That is fed into a filter network that smooths it out. In fact, if you could monitor the filter with an oscilloscope, you would see something sort of like this. It would be an almost flat line with kind of a ripply top. This is a high voltage direct current, and it is what ultimately is powering the VFD internally. Incidentally, we sometimes call this the DC link voltage. It is something that some VFDs allow you to monitor externally with a meter or an oscilloscope. Almost all VFDs can monitor the DC link voltage internally. That includes the MOVITRAC LTE-B Plus. In fact, I'll be showing you how to monitor the DC link voltage later. But at any rate, this is really what's going to be powering the motors. We do this by sending this high voltage DC into three rather large power transistors, which are called IGBTs. That stands for insulated gate bipolar transistor. But just think of these as high-speed electronic switches that can turn on and off very rapidly. The IGBTs in a VFD are connected up to a microcontroller, which is like a tiny computer, and it does a bunch of things, but one of the most important things is to pulse those IGBTs on and off. And what that does, it generates a kind of synthetic alternating current that comes out and goes to the motor. This is what the synthetic AC looks like. Now, you may look at this and say, boy, that doesn't look very much like alternating current. I'm kind of used to alternating current looking like a sine wave, and this doesn't look at all like that. Well, you're absolutely right. It's quite different, but this is an important point. As far as the motor's concerned, it is a sine wave. Now, how is that so? Well, let's dig into the details a little more. The synthetic AC is generated using a technique called pulse width modulation, or PWM. PWM is a technique where you simply switch a DC voltage on or off. You don't vary its voltage at all, and so what you have are a series of pulses. What you do adjust, however, is how wide these pulses are. You can have really skinny pulses like these, and as far as the motor's concerned, this looks like a low voltage. If a pulse is kind of medium width, it looks like a medium voltage, and if the pulse is really wide, it looks like a high voltage. So as you can see, we combine narrow, medium, and wide pulses together, and the net effect, as far as the motor's concerned, is a sine wave. But what's so brilliant about the PWM concept is that since it's developed by a small computer, you can create an alternating current of basically almost any voltage and frequency you like. And that gives you enormous flexibility in controlling things like motors. So PWM is an elegant concept that is extremely powerful, but also really rather simple. And this leads to a big idea of how a VFD controls a motor's speed, which is what you mostly use them to do. A VFD controls the motor's speed by varying the frequency of that synthetic AC. And by varying the frequency, you can vary the motor's speed. There's actually an equation. You simply take 120, you multiply it by the frequency that's being sent to the motor, and divide by the number of poles in the motor. Most motors have somewhere in the neighborhood of 2, 4, 6, or 8 poles, and these have a big influence on the ultimate speed that you can expect. Let's do a simple calculation to see how this works. Let's say that we have a 4-pole motor, which is one of the most common asynchronous motor styles, and let's say we set up our VFD to output a 60 Hertz frequency. So if you just take 120 times 60 Hertz and divide by 4 poles, you get a speed of 1800 RPM. Pretty simple. You may be wondering what kind of motors the MOVITRAC LTE-B Plus supports, and you may be surprised that it supports quite a few for an entry-level VFD. Of course, the most common type and the primary audience of this VFD is asynchronous motors, such as SEW Eurodrive's DRN series. There are 2 motor control modes built into the MOVITRAC that can support asynchronous motors. A very simple method called VF, which will work with just about any motor, and a more sophisticated method, LVFC, sometimes known as a vector mode, that gives you better speed control. We also support permanent magnet synchronous motors, such as SEW Eurodrive's CMP servo motor line. We have a motor control mode called PMVC. And then finally, we also support line start permanent magnet motors like SEW Eurodrive's DRJ series. So that covers a lot of motors, but there are actually 2 other types as well, which are a little more niche. One is brushless DC motors. There's a BLDC mode for that, and synchronous reluctance motors, which has a mode called SYN-R, which supports it. So you can see we cover your bases as far as motors. Now I've got to pause for a very important note. Of the motor modes that we've just discussed, the MOVITRAC LTE-B, in other words the older version, supports only VF mode, and therefore it only supports asynchronous motors. Probably a good incentive to buy the LTE-B+. Let's go into the different models of the MOVITRAC LTE-B+, and let's also talk about the nomenclature. These are the SEW Eurodrive codes printed on the VFD sticker, and what they really do is they tell you the features. I'll explain how to interpret what looks like just a confusing bunch of characters, but let's look at models first. The MOVITRAC LTE-B Plus is available in 2 IP ratings, IP20 and IP66. So there are 2 main models. There's the IP20 model and the IP66. Now, if you don't know what IP is, it is very simple. It stands for ingress protection, and it indicates essentially how resistant the VFD's enclosure is to liquid and solid penetration. So it's got 2 numbers that come after the letters IP. The first number is between 0 and 6, and the second is between 0 and 9. The first number indicates how resistant it is to solids getting in. If it has a rating of 0, that means that practically anything can get in. And if it has a rating of 6, it means it can keep out even dust. The second number is the resistance to liquids. If the second IP digit is 0, it means the device has no protection against liquids, and if it has a rating of 9, it means that you can submerge it. The IP20 model, as the number implies, will keep out objects that are basically finger size, so it will keep out larger objects, and it will keep out no liquids. So this one is not designed to be used in a harsh, hostile environment where it's going to be exposed to things. On the other hand, the IP66 model is dust-proof and it's resistant to water jets, which means it can even be used in a washdown situation. SEW Eurodrive sometimes calls its IP20 models control cabinet, which means that they probably need to be inside a control cabinet for their protection, since the IP rating doesn't give them a whole lot. Now, in a very clean, dry environment, they could be left out in the open, but usually they live in a control cabinet of some kind. On the other hand, IP66 models are often called wall mount because that means they can just be bolted to the wall out in the environment, and their IP rating will give them quite a bit of protection. So essentially 2 styles, 2 models connected to the IP rating. Let's look at the IP20 models first. Here they are. They come in 5 sizes, and within each size there will be several power ratings, so there are actually far more than 5 VFDs. These are available in power ratings from half a horsepower up to 50 horsepower, and the kilowatt equivalence is 0.37 to 37 kilowatts. They're available in 115 volt single phase in sizes 1 and 2, the 2 smaller sizes. You can also get 230 volt single phase in sizes 1 through 3. And you can get 3-phase models in all 5 sizes, either 230 volts or 460 volts. So lots of choices for powering your VFDs. My demo unit, incidentally, is a size 1, 115 volt single-phase model, which is really convenient for demo work since you can plug it into an ordinary household outlet. You don't need 3-phase high-voltage AC. Now let's look at the IP66 models. These come in only 4 sizes, so they do have a more restricted size range, and here they are. They're available from half a horsepower to 30 horsepower, which is the equivalent of 0.37 to 22 kilowatts. They are also available in 115 volt and 230 volt single phase, and they are available in 230 volt and 460 volt 3-phase. So again, a lot of choices, just slightly smaller power range. Notice that the IP66 models that are shown here include some front panel controls. They have a speed and direction control. They also have a disconnect switch, which can be fitted with a lock. Upon request, you can also obtain an IP66 model without these controls. It's not normally shown. I don't have any pictures of it, but it's essentially this model with these 3 controls emitted from the front. So if you need that, contact your SEW Eurodrive sales representative and they can equip you with one. Let's talk about the kind of applications that you might use a MOVITRAC LTE-B+. What's it really intended for? Well, it's an entry-level VFD, but it's got a lot of punch for its price. It's commonly used in fans and blower controls of all different sizes, ranging from small ones to huge ones. It's frequently used in conveyors, it's used in small handling machines, and it's often used to drive pumps. So these are its main applications, but there are many others, and in many ways it's limited more by your creativity than by its features. It's actually a very powerful and capable VFD. Let's go into the nomenclature that describes the features of a MOVITRAC LTE. If you encounter a MOVITRAC LTE-B+, somewhere on it will be a sticker which will have a whole string of letters, numbers, and symbols. You may wonder what those mean. Well, happily, the nomenclature for this VFD is relatively simple and easy to understand. You might see something sort of like this, MC LTE-B0015-5A3-4-00. And perhaps you'll wonder, how on earth can I interpret this? Well, it's actually very simple. Let's work our way through it and you'll see how it goes. MC LTE-B simply indicates it's either a MOVITRAC LTE or a B+. There's no way to tell the B and the B+ apart from just the nomenclature. You would have to look at other features to figure that out, but as I've said, these are very similar VFDs, so that just identifies the product. The 4-digit number after this indicates the approximate output power in kilowatts, and what you need to remember to do is insert a decimal point between the last 2 digits. So this is actually a 1.5 kilowatt MOVITRAC LTE-B or B+. The next character, which is a number, indicates the voltage. There are 3 possibilities. A 1 indicates it runs on 115 volts AC. 2 indicates 230 volts AC, and 5 indicates 460 volts AC. Next comes a letter or number. It indicates whether there's radio frequency interference suppression. If there's a 0, there's none. If there's A or B, then there's some degree of suppression. The next character indicates whether it's a single-phase or 3-phase VFD. If you see a 1 there, it's single-phase. If you see a 3, it's 3-phase. As you can see, this model is 3-phase. Then comes a number that indicates whether there is a brake chopper in the VFD or not. A brake chopper allows the VFD to dissipate braking energy with a brake resistor. This model supports it because it has a 4 here, but some models will have a 1. They do not include a brake chopper, therefore they can't use a brake resistor. And then finally a 2-digit number indicating the IP rating. 00 indicates it's an IP20 VFD. 30 means it's IP66 with no front panel switches, and 40 indicates it's IP66 with front panel switches. Pretty simple. Nomenclature is relatively painless with the MOVITRAC LTE-B. Let's take a few minutes to tour the connectors and features on MOVITRAC LTE-B and B+. We'll start with the IP20 model. All the IP20 models include a little pull-out quick reference card, and I'll be referring to this as we go along. It's a handy little thing when you're doing a setup if you don't have a manual with you. Then there's a display and keypad, an I/O connector for connecting up accessories or control wiring, connections for the motor, connections for the brake resistor if the VFD supports it, and I will mention some of the smaller sizes do not support brake resistors. There's a communications port used for both engineering and networking multiple VFDs together. And finally, there is a series of connections for the line power to come in. And that is all you'll find on the outside. Let's take a look at the IP66 models. They have the same display and keypad as the IP20 models, but all the connections are inside under this cover. Remember, this unit can keep out even water jets, so cables go in through cable glands and all the connections are safely inside. I'll show you inside in just a minute. We have a disconnect switch here, and you can pull out the front of it to install a lock if necessary. We have a direction selector and a speed control dial. So this is a nifty little extra feature not found on the IP20 models. Let's go inside though and see what's under the orange cover. Here's the inside. We have the same I/O connector you'll find on the IP20 model, except it's inside, protected from the wet and from dust. The motor connection's here. Place where the brake resistor can be connected. This is actually a cover over it that you'd have to remove. And again, remember, not all models support brake resistors. Then we have the line power in, and then finally a pair of communication ports, again for engineering or networking. And that is the IP66 model. Incidentally, you should be aware that the LTE-B model is a little bit different inside in the IP66 version, but it's quite similar. The biggest difference is it has only one communication connector instead of two, and some of the connectors are in slightly different positions. Let's look at how you control your MOVITRAC LTE-B and B+. It's got a lot of flexibility here. As I've said multiple times, this is really a very powerful VFD for its price point. One of the simplest ways to control the MOVITRAC LTE-B+ is through the front panel display and keypad. You can actually do a lot with just this simple set of controls. In fact, many people use nothing else. Let's take a look at the different things you can do with it. In most cases, buttons perform more than one function, but when you're running the VFD, here's what they do. This button starts the motor, and when it's running, it can also reverse its direction. The red button stops it. The up button increases the speed, and the down button decreases the speed. And the button in the middle, which is called the Navigate button, selects the status display that appears on the red LED display above. This can tell you things like what speed the motor's turning, how much current it's pulling, how much power it's using. So front panel control is probably your simplest way to operate it. But if you need more sophisticated control, there are other modes available. For example, there's what is called terminal or binary control, where you control the VFD with switches. To do this, you make connections to that front panel I/O connector, which is available on the front of an IP20 model or inside of an IP66 model. These are the signals that are available on it. We have several digital inputs, we have some analog inputs, we have an analog output, a digital output, and a relay contact. There's also 24 volts DC available and 10 volts DC. MOVITRAC LTE-B+ supports 14 different terminal control modes, so there's a lot of flexibility possible here. Let me show you a typical example where you would use 3 switches, a potentiometer, and an indicator. You would wire the switches up like this between 24 volts and the 3 digital inputs. These would control the mode in which the VFD operates and maybe select its speeds if you're using fixed set points. But if you connect a potentiometer up between the analog input, the 10 volts and ground, You can have smooth speed control by turning a knob. The potentiometer, by the way, should be between 1 and 10K resistance. And then finally, the relay contact can be used as a status output to indicate what the VFD is doing, and you could wire it up to an indicator light, for example, like this. So this is just one possibility. We'll talk about terminal control mode in much more detail in a later session. If you have an IP66 model with front panel controls, then you essentially get the direction control and potentiometers thrown in as part of this. So you would have a speed control knob for smooth speed control, and you would have a direction selector which selects between clockwise, counterclockwise, and neutral. Incidentally, if you have an IP66 model and you want to wire your own controls to the I/O connector, it is possible to disable the built-in controls if desired. So bear that in mind. Now, if you want to get really sophisticated with your MOVITRAC LTE-B+, you can use field bus control. The MOVITRAC LTE-B+ supports several what I call classic field bus standards, and I call it that because these have been around for several decades now and they're well used. Out of the box, it supports S-Bus, which is an SEW Eurodrive field bus. We also support CAN Open and Modbus RTU. And if you want to use some other kind of field bus, there are other possibilities if you install a gateway between the MOVITRAC LTE-B+ and the field bus. We'll talk about that more in a later session. When you're connected up in field bus mode, you can network multiple VFDs together and connect them to a PLC or other industrial controller, and it can send commands over the field bus telling the VFDs what to do. We will cover that in our last session. This is the connector you would use to connect up a field bus. It's the multi-purpose communications connector on the front. We also use this for engineering, but in a field bus setting, this is where you connect the field bus. You would need what's called a splitter cable in order to wire up a field bus. You can see how it's wired with cables going in and out from the splitters, which go to the communications port. There's also a terminating resistor that you need to put at the very end of the chain. These are sold in cable sets from SEW Eurodrive, and I'll talk about those more in just a few minutes. If you have an IP66 model, however, you don't need a cable splitter because it's got 2 communications ports built in. So this is automatically there to enable you to do field bus control and other types of networked control. Kind of handy. Unfortunately, the LTE-B model only has 1 communications port inside the IP66 model, so you'll have to try to fit in the cable splitter. Yet another advantage of having an LTE-B+. Let's briefly cover the accessories available. These can expand your MOVITRAC LTE-B+ and enable it to do other things. First of all, let's look at a few communication accessories. SEW sells a remote keypad. This allows you to have the keypad in some location separate from the VFD. You would connect it up by a cable. You might, for example, put this on the front of an enclosure or somewhere closer to the application that you're operating. There's also a more deluxe keypad that has a full-text OLED display, which is rather nice. We have a Bluetooth module, which allows you to engineer the VFD wirelessly without having to plug a cable in. You just plug the Bluetooth module in instead. The Bluetooth module also stores the complete parameter set of a VFD. What's really nice about this is you can use it to copy the parameters out of one VFD and then go down the line of a bunch of brand new VFDs and duplicate the parameter set into each one of them at just the touch of a button. So if you're setting up a lot of VFDs, you might want to get a hold of the Bluetooth parameter module. If you're going to use a PC to engineer your VFD, then you'll need a USM21A USB adapter. This converts from USB to the RS485 signals that the VFD requires. You'll also need what's called cable set C. It's the engineering adapter. You plug this into the VFD and you plug the USM21A into it. So that is used for engineering. And if you're going to set up a network of some kind for field bus control, you'll need either cable sets A or B. These include things like the splitter, RJ45 cables, and terminating resistors. So these are all listed in SEW Eurodrive's catalog. You can look at these or speak to a sales representative. There are a number of expansion accessories that extend the capability of the MOVITRAC LTE-B+. These all connect to the I/O connector, and they have a pass-through connector as well, so you can wire up to them. Here are the modules available to expand the MOVITRAC. The second relay module gives you a second relay if you need two separate relays. What it does, it uses the analog output and converts it to a relay output. There's also what's called the two-signal relay module. It converts the built-in relay, which has just one contact, to a double relay, so you have two separate contacts that can indicate two separate signals. And then this module looks the same, but it's different. There are two modules available that allow you to take either 110 volts or 230 volts and feed that directly into a digital input without damaging it. The digital inputs normally can only handle low voltage DC. These modules allow you to use a higher voltage as a digital signal, so they're rather handy. And then finally, there are some electrical accessories to help condition the inputs and outputs, and also to deal with what's called regenerative energy that occurs when the motor is braking. For this, you would need a braking resistor, and you can see braking resistor goes right into the enclosure. It's available for sizes 2 through 5, so they're not available for the smallest version. But if you're dealing with a lot of regenerative energy caused by the motor braking, then you'll need a brake resistor. We also sell chokes and line filters. These condition the input and output power to make them cleaner and to deal with certain electrical situations that may come up in your application. You would wish to speak with an application engineer if you're confused about how to use these. And that is the list of accessories available with the MOVITRAC LTE-B+. That is also the end of session 1. In our next session, we're going to get into how to install a MOVITRAC LTE-B+ and how to start it up using Quick Startup. See you then.